Yeah, I see you on the screen. And I just stepped into the room. Then, my colleagues advised me that the first speaker is answering a few questions, It's not online yet. That's a big surprise for me, I invited him to give the speech. So just give us a couple of seconds. So let's see whether we'll be able to move the full speaker, to be the first one. Yeah. Please, apologize. Yeah. Do give us a little patience. Sorry for that disconnection. Yeah. Oh.
看一下，
来了吗？
就是 speaker 应该都在上的，
是吗？没看，他没来是吗？
对，我刚才好像看见他们闪了一下，可能就掉线了。
这是王征吗？王征应该是年轻科学家是吧？或者这之前。Now at the Research Center for Eco-Environmental Sciences, and he is doing the conversion of green gases, CO2, and water splitting based on photocatalysis and photothermal catalysis, and he has some good publications in good journals. So without further ado, Professor Wang, you take the floor. Thank you.
Okay, thank you, Chairman. Can you hear me?
Yes, we can hear you clearly.
Okay. Just a moment, I share my screen.
Yeah, share your screen, share your slides in a full screen. Yeah. No, we only see you, but not.
Is that okay? Can you see the PPT?
Yes.
Okay. Thank you, Chairman, for a nice introduction. And good afternoon, ladies and gentlemen. This is Zheng Wang from Chinese Academy of Science Research Center for Eco-Environment Science. I'm first grateful to the committee for giving me this chance to share my research and discuss with you. Today, my topic is the photocatalytic carbon dioxide conversion and water splitting towards artificial photosynthesis. And this is my education and work experience. And during the work in Japan, I participated in the artificial synthetic chemical process project from 2015 and 2019. Now I'm working on the carbon dioxide reduction and water splitting using the solar energy conversion technique. And with the increase of the social production and activities of human beings, the global average temperature increase obviously, resulting in the serious eco-environment problems. The temperature anomaly is due to the emission of larger amount of greenhouse gas carbon dioxide into atmosphere. These two figures shows the concentration of carbon dioxide in the atmosphere and the emission of carbon dioxide in each region. sharply increased in recent 100 years. And the emission of carbon dioxide gas originate from the combustion of lots of fossil fuel. As shown in the figure, more than 80% of world energy supply is from the fossil fuel. And the world main primary energy source are still fossil fuel in the future 20 years. The renewable energy consumption is quite small. Moreover, the storage of the fossil fuel on Earth is limited. Therefore, from the viewpoint of environment and energy, it is necessary to investigate the clean energy conversion combining with the carbon dioxide conversion and the utilization to achieve a sustainable carbon neutral society. In nature, green plants can convert carbon dioxide and water into the organics, such as biomass, using the sunlight. Solar energy is a clean, sustainable energy source. A nuclear solar energy reached on Earth is 5,000 times as a newer global energy demand. Inspired by the nature photosynthesis, solar energy conversion into the hydrogen energy and high-value carbon-containing chemicals through water splitting and carbon dioxide reduction is a promising way to solve the environmental problems and the energy crisis. However, the innovative technologies are highly required to promote the development of renewable energy conversion and accomplish the carbon neutrality. China has declared the development of liquid sunshine strategy in 2018. Liquid sunshine is the vision of combining the solar energy with carbon dioxide and water to produce green liquid fuels. And the carbon dioxide released from these liquid fuels is recycled back into the environment. And the main target liquid fuels are methanol or ethanol. The next figure shows the liquid social fuel production demonstration project was established in 2019. In this project, photovoltaic power station supplies the electricity for the electrolysis of water to produce hydrogen. And this green hydrogen will be used in the hydrogenation of carbon dioxide to produce green methanol. As we know, there are three primary techniques for the solar energy conversion to produce the high-value chemical energy. Photovoltaic electrolysis and photoelectrocatalysis are electrode systems. And the photocatalysis is a particulate catalyst system. According to the technical analysis of the artificial photosynthesis, the energy conversion efficiency for the photovoltaic electrolysis is higher than that for the photoelectrocatalysis and photocatalysis. But the capital cost of the photocatalysis is the lowest among the three techniques. Moreover, based on the solar light irradiation feature, the solar energy conversion system scale must be enlarged to receive sufficient solar irradiation. As shown in the figures, this is a panel reactor for the solar water splitting. Particulate photocatalyst can be fixed on a large area plate by a cheap, simple process. Therefore, the photocatalysis based on the particulate photocatalyst is regarded as a technological, simple, scalable, and cost-competitive approach toward sustainable solar fuel production. In artificial photosynthesis, there are several fundamental reactions: carbon dioxide reduction to valuable chemicals and water splitting for hydrogen production. If the water was used as the electron donor for the carbon dioxide reduction, the reactions are highly and thermodynamically difficult. Particulate photocatalysis are possible to accelerate this reaction occurring at a normal temperature and pressure. And in the photocatalytic reaction, there are 3 steps. First, the electron hole pairs generation in the bulk of the photocatalyst by the light absorption, and the charge separation and migration to the surface of photocatalyst, and the surface catalytic reaction. Therefore, we face 3 problems and challenges in the particulate photocatalysis. First is narrowing the band gap energy of the photocatalyst to expand the visible light absorption will decrease the driving energy of the photoexcited electron holes. Photoexcited charges are easily recombined at defects of the photocatalyst during the migration and transfer. Reverse reaction between the reduction and oxidation products usually takes place at the surface site. With these challenges, first I show the result of the photocatalytic overall reaction of carbon dioxide reduction and water oxidation. In the photocatalytic conversion of carbon dioxide, we aim to achieve the simultaneous occurrence of the carbon dioxide reduction and water oxidation. That is, water supplies the electron for the carbon dioxide reduction. Another target is to suppress the competing hydrogen evolution reaction, which consumes the electron used for the carbon dioxide reduction. First, we synthesize the layered perovskite type lanthanum titanium oxide photocatalyst by the polymerized complex method. SRD shows well crystallinity of this sample, and the absorption edge is located at around 320 nanometer. Silver co-catalyst particles loaded by the chemical reduction method were dispersed uniformly on the lanthanum titanium oxide materials. Photocatalytic conversion of carbon dioxide with water was carried out using the silver modified lanthanum titanium oxide. The gas products, carbon monoxide, hydrogen, and oxygen were evolved in a stoichiometric ratio. That is, the number of the electron consumed by the formation of carbon monoxide and hydrogen was equal to the number of hole used for the oxygen production. This means the hydrogen functioned as the water functioned as the electron donor for the carbon dioxide reduction. Moreover, the 13 carbon labeled carbon dioxide was used in the isotopic labeling experiment, confirmed that the carbon monoxide product was originated from the introduced carbon dioxide gas, not from the organic pollutant. We also synthesize spinel type zinc gallate photocatalyst by the solid state reaction method. Through the optimization of the synthesized temperature and time, high photocatalytic overall reaction activity for the carbon dioxide reduction with water was achieved. Silver is an effective co-catalyst to convert carbon dioxide into the carbon monoxide. As compared with different loading methods, chemical reduction method gives the homogeneous dispersion of the silver particles with uniform particle size. And the best overall reaction activity for carbon dioxide conversion with water was obtained on the silver modified zinc gallate by a chemical reduction method. And the selectivity towards the carbon monoxide in the reduction product was as high as 95%. Moreover, the gallium oxide is another efficient photocatalyst for carbon dioxide reduction. With silver co-catalyst loading, high activity for the photocatalytic carbon dioxide conversion with water was obtained, while hydrogen was the main reduction product. After the zinc modification on the surface of gallium oxide, hydrogen production was dramatically suppressed. XRD and ZAP's result indicate the formation of zinc gallate layer on the surface of gallium oxide by modifying the zinc species. And with the increase of zinc modification, hydrogen evolution in the photocatalytic carbon dioxide conversion was gradually decreased, indicating the thin gallate layer eliminates the active site for hydrogen production on the gallium oxide. Moreover, the fine regulation of carbon monoxide and hydrogen ratio in the photocatalytic conversion of carbon dioxide suggests a simple and a clean technique for thin gas production. Surface modification can not only suppress the competing hydrogen evolution reaction, but also enhance the carbon dioxide adsorption and activation on the photocatalytic surface. When modifying the gallium oxide with lanthanoid oxide, the activity for the photocatalytic carbon dioxide conversion with water was promoted obviously owing to the enhancement of carbon dioxide capture and activation by the surface base site. When modifying the tantalum oxide with the alkali earth metal oxide, the photocatalytic performance for the carbon dioxide reduction with water and the selectivity of the reduction products were improved. And the above result demonstrated the base site modification is effective in the photocatalytic carbon dioxide conversion. Next, I will show the results on visible light-driven overall water splitting. Tantalum-based oxynitride, such as tantalum 3N5 and barium tantalum O2N, are well-known photocatalysts in the field of water splitting. They are the 600 nanometer class material with simple and stable crystal structure and having advantage and potential for the efficient water splitting reaction. Tantalum nitride has the simple chemical composition and the narrow band gap energy, which is suitable for the reduction of protons and oxidation of water. And the conventional tantalum 3N5 produced from the tantalum oxide by the long-term nitridation has large defect density, aggregated particle, and unstable surface condition that are detrimental to the overall water splitting reaction. We developed a unique potassium tantalate precursor having matchable lattice parameter to tantalum nitride and the volatile potassium component to produce the high-quality tantalum 3N5 photocatalyst by a short-term nitridation process. As shown in the SEM and HRTM images, after a short nitridation process, tantalum 3N5 nanorods were selectively grown at the edge of cubic potassium tantalate particle. Such nanorods formed on the potassium tantalate were single crystals without any distortion from the surface to the interior. Tantalum 3N5 nanorods were selectively grown at the edge of cubic potassium tantalate. It is because tantalum atom distance in the potassium tantalate 110 plane is close to the lattice distance of the tantalum 3N5 100 first set, and the potassium atoms in potassium tantalate 110 plane are exposed to the surface. Therefore, during the high temperature nitridation, potassium species were quickly volatilized from the potassium tantalate 110 plane, and resulting the faster growth of high crystallized tantalum 3N5 nanorods. Through the selective deposition of metallic rhodium nanoparticles and manganese oxide on tantalum 3N5 nanorods, it is confirmed that the active sites for the photoreduction and photooxidation were located on the tantalum 3N5 nanorods. Under the visible light and the simulated sunlight radiation, tantalum 3N5 nanorods single crystals which grow on the potassium tantalate were able to decompose water into hydrogen and oxygen with a stoichiometric ratio of 2 to 1. And this is the first time to achieve the one-step excitation over water splitting on the well-known tantalum 3N5 material. Barium tantalum O2N is a perovskite type photocatalyst materials can harvest 660 nanometer visible light. It was usually synthesized by high temperature nitridation of barium carbonate and tantalum oxide mixture. The crystallinity of the obtained sample is low and the particle was aggregated. We introduced the alkali metal chloride as flux into the nitridation process. With the assistance of the flux, barium tantalum O2N crystal grow well in the short-term nitridation, and the obtained sample had high crystallinity and uniform particle size without aggregation, indicating the structure and band gap defects decreased a lot. Among the various samples fabricated with different flux, the rubidium chloride assisted barium tantalum O2N exhibited the best photocatalytic activity for hydrogen production from the methanol solution under the visible light irradiation. Therefore, we selected this sample fabricated with rubidium chloride to investigate the effect of co-catalyst modification. Platinum is an efficient co-catalyst for hydrogen evolution used on the barium tantalum O2N. First, the impregnation loading method can make the platinum particles contact well with the barium tantalum O2N, which can facilitate the photogenerated charges transfer between the interface. However, the aggregation of platinum particles occurs when the loading amount increases. And the photodeposition method can cause the selective loading of a platinum particle at reduction active site on the barium tantalum O2N. But the platinum particles are aggregated and have weak interaction with barium tantalum O2N. Here we developed a sequential co-catalyst decoration method, which combined the advantages of the impregnation and photodeposition. First, a small amount of platinum was loaded by impregnation process, which can result in the high dispersion of platinum nanoparticles on barium tantalum O2N and in intimate contact with the barium tantalum O2N. This highly dispersed platinum nuclei functioned as active sites for the subsequent photodeposition process. Therefore, the platinum co-catalyst nanoparticles with uniform size, high dispersion, and strong interaction with the barium tantalum O2N can be obtained by this sequential decoration procedure. These platinum co-catalyst nanoparticles were able to extract the photo-generated electrons from the barium tantalum O2N efficiently. And platinum-loaded barium tantalum O2N by the sequential decoration method gave obvious enhancement of the photocatalytic hydrogen production in the half reaction. And the apparent quantum yield values at 420 nanometer were 6.8%. When combining with the surface-treated tungsten trioxide, iodide, and iodine as the redox couple, the efficiency of this scheme over water splitting was improved a lot. The solar to hydrogen energy conversion efficiency was 0.24%. And this is the most efficient Z-scheme water splitting system constructed with the 600 nanometer class photocatalyst. And that's all for my presentation. Here are the conclusions. Thank you for your kind attention.
Excellent talk, but I'm afraid that it involves more technical jargon, than I actually wished. So you actually feel to give this in a summary. Can you just use some simple words to sum up your presentation?
So,
yes, you use some of the layman's language, so you you have more public understanding of the importance of your research breakthrough.
Yeah. So to achieve the carbon neutrality and the sustainability, so the artificial photosynthesis is a promising way, and photocatalyst based on the solar energy conversion technique, the particulate photocatalyst is a simple to obtain the clean energy, such as the water splitting and carbon dioxide reduction. And here, yeah, although the efficiency of this technique is low, but we hope and we expect the efficiency can reach the purpose. That means can be applied in the industry application. Yeah.
Okay, I actually very much enjoy this topic. And how successful you think you are or we are from actual application? Is there a challenge for you to find investors? I know that somewhere you have to put it into commercial application. On the one
Yes.
hand, you are increasing efficiency. On the other hand, I'm sure that you are looking for investors and also work on the application part of the story.
Yes. For example, the photocatalytic water splitting. Now the big problem is the efficiency is not high. That means the solar to hydrogen energy conversion efficiency is not so high. But the capital cost of this technique is low enough for the application. But the problem is the efficiency. So
okay, so efficiency, but my understanding of this topic is that people talk about creating the big international collaboration program called Liquid Sunshine, because we need to put our acts together from various parts of the world in order to achieve high efficiency by photosynthesis to achieve renewable energy.
Yeah. So.
So
yes,
it needs international collaboration, in other words.
Yeah, maybe now is we need more fundamental investigation and research and collaboration. So to get the more efficient photocatalyst materials, and this can solve the future problems. And this is the final target.
Okay.
If we achieve the application.
Yeah, thank you so much. And because of time, let's move to the next speaker. And
okay.
So the next speaker is Dr. Kapuna Sava, a doctor in nuclear engineering and management from Tokyo University. He made shift in his research focus. Now works on enhancing energy resilience in renewable energy systems, and a lot of publications. And he is now the co-chair of the Thai Young Scientist Academy, and also an executive committee member of GSPS Alumni Association of Thailand. Looks like he's young, and his talk is entitled "Roles of Renewable Energy in Achieving Carbon Neutral: Research Direction and Necessity in Policy Support." Yeah, young guy. Yeah, Dr. Sava.
Hey, thank you very much, Chair, for your kind introduction. So I'll start my presentation. Okay, so I hope you all can see my screen well. So good afternoon again. I'm Kampanat Silva from the Renewable Energy and Energy Efficiency Research Team actually it's a new technology center under NASDA. It's National Energy Technology Center or NTEC. And my talk today, well, as introduced by the chair, is the roles of renewable energy in achieving carbon neutral. So my talk will be quite broad. So I'll talk about the research direction that we will be following, and also we'll touch a little bit about the necessity in policy support. So a little bit about the new technology center, National Energy Technology Center or NTEC. It was officially founded under the NASDA in June 2020. So it's very new, like it's the 5th technology center under NASDA, specifically working on energy-related research. Well, these are the visions and mission of NTEC. So the vision is to be a leading organization and a focal point of Thailand's energy technology development. And well, I think the missions are basically very similar to other technology center. So we'll do research and development, and also, well, about the comprehending knowledge in supporting Thailand integrated energy blueprint, and also working toward impacts, and also work hand in hand with public and private partners, because we think that, well, now we cannot walk alone anymore. We need to work both with all other public organizations, with the universities, and also with the private sector. And finally, the last mission is to integrate major resources from various channels for prompt actions. So we thought that, well, as a new center, we try to work more rapidly, more faster, in order to meet the expectation of the government and of the private sector. So these are the research focuses of the National Energy Technology Center. So there are main 5 focuses. The first one is the renewable energy. Second one is the energy storage. So you see that actually the energy storage itself also support the renewable energy research and distribution quite a lot. And also we do the research on conventional energy, more specifically about the biofuel, the mix of biofuel with a conventional fuel. And also we are extending the research scope to cover the system integration and energy management, mostly all of those related to photovoltaic, and also energy efficiency, which is not only about the energy system, but also, for example, electric vehicles and also other type of vehicles. And you see the last one, it's like the arrow underneath. It's actually energy policy and energy resilience, because we thought that, well, actually to bring all this research and development into practice, we need good support from the policy makers, and also we need the good support of all the decision makers. And I will come back to this a little while later. So as the topic today is about the clean energy, and it's about the working toward carbon neutral, so I'll be focusing on the 2 important focuses of NTEC, which are renewable energy and energy efficiency. So for the renewable energy, NTEC aims to develop and commercialize renewable technologies. So when we say renewable technologies, the things we are focusing on are, for example, palm-based lubricant, biofuel, PEV model, photovoltaic model, and also application and management, and also about the low wind speed turbine. So different types of renewable energy research related to renewable energies are being conducted here in NTEC. And also you see here that we are also doing research related to life cycle management in order to pursue sustainable development, and also circular economy promotion, which I believe you listened to in the morning. The other focus is about the energy efficiency. So when we talk about energy efficiency, basically it's all the work toward the reduction of energy intensity. But also our focus is also about the contribution from the energy sector to the Thailand national determined contribution, which is like the target of carbon dioxide emission reduction. So that's about the mitigation, but also we also think about the climate change adaptation. And also in the field of energy efficiency, we are having quite a lot of collaboration with the industries and policymakers. So these are some examples of the work that we are doing with international partners. The first one is actually the work that we are doing with the ASEAN Center of Energy. It's the study on regional biofuel research and development mapping. So we get together with all the researchers who are working on biofuel to see that what kind of research and development that we should do in order to go further with this promotion of biofuel in the future. The next one, shift from ASEAN to APEC. We are also working quite a lot with the APEC working group on energy. So I think they call it Energy Working Group. We are actually working through the Department of Renewable Energy and Energy Efficiency, or DEDE, under the Ministry of Energy. So I will be introducing two of our projects. The first one is the Exploring Co-Benefit Opportunities for Renewable Energy and Energy Efficiency Projects in APEC region. So we have seen quite a lot of projects in APEC that are working toward the promotion of increasing the sharing of the renewable energy. And also, on the other hand, we also see a lot of projects that aim to reduce the energy intensity in the usage, for example, in transportation sector, in power sector, and also in building sector. For APEC, actually, they have been doing quite well in pursuing the goal of the energy efficiency, but they are not being able to reach the target of the renewable energy yet. So we were thinking that, well, what would be the good way? So what would be the good area of focus that we need to go in order to use the pool of people who are working on energy efficiency to make them also answering to the target of the increasing the sharing of renewable energy. And these are the keywords that we found, for example, flattening peak demand, low carbon, digital or electrification. So you see here that actually on the number 2, low carbon, is actually one of the very, very important keywords here. So I think this working toward carbon neutral is actually a very good direction that Thailand, ASEAN, and also APEC needs to go toward. So we are actually making a proposal to the Energy Working Group in APEC to include this focus, for example, this flattening peak demand, low carbon, digital, and so on, as the focus of the APEC Energy Working Group projects in the future. The other project we are working for APEC, again, under the Department of Renewable Energy and Energy Efficiency. And actually, the lead of this program, I mean, the lead R&D team is actually not NTEC, but ADISET in Chiang Mai Ratchapat University, but we are working together. So this project is on accommodating disruptive technology into renewable energy and energy efficiency policies for energy security. So we thought that another thing that we need to really think about quite a lot is about the disruptive technology, which will actually help a lot to increase the share of renewable energy and also to pursue the target on carbon neutral in the future. So you see that, well, actually, when we talk about renewable energy and energy efficiency, sometimes, well, until now, people have been talking about them separately. But when we use this carbon reduction or carbon neutral as a keyword, then we see that this carbon reduction can be something that we use to combine or to connect the research and development in the field of renewable energy together with the research and development on energy efficiency. So I will move to my latter part that I say that I will revisit again, which is the arrow underneath energy policy and resilience, which is actually something that National Energy Technology Center is also looking at quite a lot. So we see that, well, actually, in order to link this renewable energy and also energy efficiency research into practice, we need very good supporting policy. And also we need very good concepts that could actually be understood by the policymakers in order to have them work together with us. So for energy policy and resilience, so we put it also here that NTEC aim to achieve sustainable use of innovative energy systems in order to get in line with the United Nations Sustainable Development Goals. And we had actually one of a pilot project on the evaluation of resilience of various renewable energy systems. So we believe that the R&D on energy policy and resilience will support smooth translation of research outputs from all other 5 main pillars to the actual applications. So, well, a little bit into detail about energy resilience, where actually this resilience is a concept being spotlighted everywhere. You see from the left-hand side that, well, actually, when we talk about United Nations Sustainable Development Goals, the word resilience is used when we talk about the target in goals 1, 11, 13, and 14. So we talk about resilience of the people in the goal of no poverty, resilience of the cities and communities when we talk about urban planning or city planning, and also resilience of the climate when we talk about climate action. And on the right, you will see that the publications on resilience in Scopus is actually increasing dramatically, especially after 2015, after the SDGs have been announced by the United Nations. Actually, resilience is the concept that is also being applied in the energy domain. So until now, when we talk about energy and the risk of the energy toward, for example, disasters or toward climate change, we have been talking about preparing the system to be able to absorb the change or to be able to withstand the climate change. But with this concept of resilience, we are talking more about the recovery after the system was damaged or become out of order because of climate change, and also the adaptation in the long time frame of the energy system. So we had a study actually to investigate the landscape of the energy resilience related research until now. And you see, well, actually with no surprise, the concept of energy resilience is being researched in conjunction with climate change, in conjunction with sustainability, and actually to go a little more into technical studies, also resilience is being mentioned a lot when we study about distributed energy resources or microgrid, and also about the smart grid. And a little bit about our pilot project on energy resilience assessment. We went to the real renewable energy system, so including on-grid solar, commercial biomass, off-grid solar, and also community biogas, to try to assess the energy resilience capacity of these systems. And we saw that all the representative energy systems are vulnerable to natural disasters, and it needs climate adaptation strategy. And at the same time, we also found that they are exposed to man-made and technological disasters. And again, not a surprise that the common vulnerabilities are lack of planning, lack of capacity for maintenance and restoration. So it's actually linking a lot to the figure I showed before, that we need to think a little more about recovery capacity and adaptive capacity of the energy system. And the resilience enhancement measures actually lead to potential cost reduction when we do like the long-term risk assessment and long-term cost-benefit analysis. So I don't want to eat up a lot of time. So these are my concluding remarks that NTech conducts various research and development in the field of energy. So renewable energy, energy storage, conventional energy, system integration and management, energy efficiency, and also energy policy and resilience. And all R&D activities are directly or indirectly related to carbon reduction, as you see from some examples that I pulled off. And promotion of renewable energy and increase in energy efficiency play very important roles in energy domain in achieving the carbon neutral. And we see from some of our studies that the policy support is also a crucial element for pushing forward energy-related carbon neutral initiatives. So finally, R&D on renewable energy, energy efficiency, and energy resilience contributes not only to carbon reduction, but also to sustainable development, as you can see from the landscape of the energy resilience related research that I showed before. So here, I would like to end my presentation and also welcome any questions. Thank you very much.
For your very comprehensive, analysis of different aspects related, to renewable energy and energy efficiency. And you mentioned about your center, as young as you are, and also, your strategic focus, and also, thanks for your elaboration on your interpretation resilience and importance that for the scientists and the policy guys to educate and communicate the decision makers, without the decisions. The planning, as you mentioned, is very important. And they said lack capacity, so we all need to address them collectively. So with that, I want to seek a question or two from the audience. If we don't, if we don't, perhaps you can answer me. From your perspective, let's see look at ASEAN countries, or from Thailand point of view. In what areas you think there is a possibility to enhance regional collaboration, or with China? I guess that solar, may not be a key priority, but palm-based, bioresources-based efficiency can be consideration.
Okay, thank you very much for the question. Well, actually, as you said, for ASEAN countries, we have a lot of palm production. That's the reason that we are building the ASEAN biofuel R&D roadmap, because we think it's one of the very important areas that we will need to focus. But actually, I would like to also say that solar is also one of our focus, because you see that the solar intensity in Thailand is actually very good, and you will see actually growing number of solar farms in Thailand. So, and now also the unit price of solar is coming down quite a lot. So it is also one of our important focusing area that we will be working on within our 5 years time frame, research time frame. Thank you very much.
Thank you. So I obviously misunderstood that, but I know that you have a lot of, but I considered maybe precipitation, no, obviously I was wrong. Yeah. Thank you for your excellent, presentation. Let's move to the next speaker. And we're pleased to have Dr. Peter Land, and a senior professor from Hungary Academy of Sciences. One uniqueness about this guy that he has served as a bridge between China and lots of universities in Europe in the renewable energy collaboration. For that, I want to thank you, very much, deeply. Finland, no, suggested by Hungary Academy of Sciences, but from Finland. Okay, so also thank to the Hungary Academy of Sciences for the recommendation. So Peter Land, a professor of advanced energy systems at Aalto University, Finland, and has more than 40 years experience in clean energy technology, systems, and policy, and an activist and strong promoter international collaboration, particularly the collaboration with China. And thank you for the important bridging role you played in the past. We hope you'll continue to serve that role in the future. He is Vice Chair of the Finnish Climate Panel advising ministries on climate change and served a very important role for many energy programs worldwide and businesses, and member of the Finnish Academy of Sciences and Letters and Swedish Academy of Engineering, a person, with a lot of distinguished international awards. Dr. Land, please. You have a Chinese name, let me use the English.
谢谢. So thank you very much, Professor Wang, for this very kind introduction. And it's really my great pleasure to be here with you today. And so my talk is about sharing the experiences of early decarbonization efforts in Europe. Europe has very challenging goals and ambitious policies to be carbon neutral by 2050. And some countries have already leapfrogged in this development. And those experiences I would share with you today. Now, in terms of putting the carbon neutrality into the global frame and to see what's the challenge, I think this figure very well depicts what we need to do. In order to meet the Paris Climate Agreement targets by 2050, we need to be carbon neutral by that date. So the carbon sources and the carbon sinks need to be in balance. You see that the emissions reductions plays a key role. They need to be really reduced by up to 80% by 2050. But increasingly, and I think that's an important observation we see also, and it's the red part in this curve, shows that the role of sinks, carbon sinks, will be important. So to reach carbon neutrality on a global scale by 2050, it's not enough just to look on emissions, but it's also important to look on the carbon sinks. They may be technical sinks like CCS, but also bioenergy is a very important biogenic sink, which we may need. So approaching carbon neutrality, the role of the sinks will, in relative terms, increase quite much. The pathway down the blue curve in the previous slide, that's clearly based very much on new technologies now, on renewable energy. Just reflecting here on one of the latest scenarios by the International Energy Agency, clearly shows that yes, it's renewable energy which will replace fossil fuels, both in the primary energy demand and electricity. Bioenergy is definitely an important source. It's worldwide. It is the major renewable energy source, and so bioenergy, when we look on renewables, it plays, of course, a very important role. So it's interesting. So bioenergy now may have a triple role in the future, as an energy source, but also as a sink, and as of course a raw material for forestry industries. So how do we have a trade-off between these three uses of bioenergy or biomass is an important question, of course, for all nations. But in some way, we need all those three aspects to come up with a solution for carbon neutrality. In case of electricity, if looking worldwide, it's really where we see a huge progress in introducing renewable energy, solar, wind, also bioenergy in some range, but it's really solar and wind where we have seen huge leapfrogging. And of course, China has played a central role of bringing these new technologies into commercial scale. There has been a major, I would say, energy revolution in this sense of bringing the cost down of solar and wind, where the Chinese efforts, I think we need to recognize those as extremely important. Now, reflecting on Europe, these global developments, I would say the European development need to be about the same. We see the same kind of a decreasing trend. We need to reduce the emissions radically. The energy sector in Europe plays about a 3/4 role of all emissions. So that's where we need to do very much. It's again, a question of reducing the emissions from the power sector, from the industry, from the buildings. So coming close to 2050, which is the target for Europe to be carbon neutral, we see that some sectors are very difficult to decarbonize, like agriculture, where we get our food. So in a way, carbon-free agriculture is quite difficult because there's always the land use change in agriculture when you plow the fields. And that's why we also, in the European case, we see increasingly important development of the carbon sinks by 2050. So without carbon sinks, and that's where bioenergy, biomass, forests will play an important role, as we see. I think this would be very hard for Europe to be carbon neutral. Now, the whole field, whole frame of carbon neutrality in Europe is policy-wise embedded in the European Green Deal, which has as a first kind of a milestone here by 2030 to reduce the emissions by 55% from 1990, and then by 2050 we would be around 10-15% emission level, and the rest would be compensated by sinks. This kind of large changing the whole energy system, you could say, is a societal question also, and that's why Europe indeed points out the importance of a just transition. So everybody has to have the opportunity to be in the transition. So you need to look on really social compensations between countries, between people within the country, so that everybody has the possibility to be in this large change that we have. So we could say everything in the society would be affected by the change. I think this is one important systems kind of a observation. And it's not just about changing technologies when we speak about decarbonization, but it's also changing our society. We need to change our norms, laws, even business models, and the consumers. We need to adjust with the new technologies that we have. So indeed, the social behavior, the social technical part is very important, which we now start to understand much more important. Also, as we build, let's say, for instance, large wind energy installation close to population, the social acceptance or public acceptance is not always clear, and that's why we need to understand how our technologies interact with people much more carefully. At the same time, Europe when it reduces the emissions in this way, it has a very important target that the economy would grow. So so one of the essence of the Green Deal is to decouple economic growth from energy and emissions. So the economy can still grow, but the emissions would come down. And this is important. We need to look on the welfare of the living standard of our people at the same time when we reduce the emissions. So decarbonizing our economy is maybe the essence here. Now looking more carefully on the European states within the European Union and their capabilities, their possibilities, their starting point for reducing emissions, we see that Europe is very heterogeneous. It's not homogeneous. So the countries, in terms of their energy mix, as you see here, they differ very much. So those countries with very much fossil energy, you see it's in the red color here. Then we have the countries with a lot of renewable energy and clean energy. That's the green part. But on average, 70% of the energy in Europe is still fossil energy. And we need to get most of that rid by the 2050. So huge effort indeed. Now, I picked here a few countries where the green part is large, with a lot of renewable energy, mainly bioenergy. Actually, bioenergy in Europe, very often you may hear about very much wind energy in Europe or solar, but now it's bioenergy which is the main renewable source. Close to 60% of the renewable energy in Europe is bioenergy. And indeed, if I pick the northern countries here, like Finland, Sweden, Norway, and the Baltic states, bioenergy plays a very important role. And of course, we have a lot of hydropower. So hydropower and bioenergy would be our indigenous energy sources in the northern part of Europe. And that's a very good starting point for decarbonization in a very more accelerated way. So the starting points for some of the countries here shown on the picture, the starting point for decarbonize quickly is there. So I think the first decarbonized nations worldwide, most likely you will see from this set of Nordic countries. So let me look more carefully on this northern part of Europe, which is shown here on the left-hand side with the red color. That is a region which is already very far in decarbonization based on its natural conditions, as said. Bioenergy, a lot of wind power, and a lot of hydropower. The hydropower forms more than half of the electricity that we need. And it's a very important balancing element when we put a lot of wind, which is fluctuating, or solar. Hydropower is a huge energy storage in a way. But more importantly, the energy markets have been integrated over the years. Since 30 years, you could say, the electricity markets have been integrated into one market, where you see very good inter-country, trans-country capabilities of power transmission. The countries are well connected, and there's a well-functioning electricity market. So if I would have much wind energy, I can always buy from the market the remaining power, which would be most likely then hydropower. So in that sense, the market takes care of many of the systems issues which you would have with integration of, for instance, wind power in the system. Looking on the future scenarios of this region, where would the Nordic region go, which is already almost decarbonized in its power, is that in terms of the power production, it's really the wind power which starts to replace thermal power plants. So wind and hydro together by 2050 may have a share of around 80% of the electricity and even beyond. This means that our electric sector in Finland and the Nordic countries, northern part of Europe, would be zero emissions by around 2030. And after that, you could start to use electricity through sector coupling to decarbonize heating, decarbonize transport and mobility, and also industries. So electricity, in our case, would be very important because there's no emissions. So using that in larger scale may help decarbonizing some other sectors which would otherwise be very difficult to decarbonize. So this seems to be the trend that we have. Now let me pick now one country, my home country, Finland, as an example. What does this kind of a market integration, making use of a larger market that we have, how would that help a single country like Finland to move forward to decarbonization? Finland has an official decision to become carbon neutral by 2035, so 15 years ahead of the Paris Agreement or the European Green Deal. And the reason for that is of course we have this Nordic zero emission electricity market, but also because of our very large bioenergy resources. Finland has the largest per capita forest resource in Europe. We are a forest-rich country, as many Asian countries, South Asia, and also China as a major bioenergy and forest resource. And in our plans, we will use our forestry resource in a way as a trade-off. Yes, we need bioenergy to replace fossil fuels, but also use the forest as a sink. So by 2035, our emissions from the energy system and the carbon sinks would be in balance, and that would be the carbon neutrality point. And after that, we foresee that we could even be a negative emission country, so have negative emissions beyond 2035. So how in doing that is indeed electricity is important, as discussed. Forests are important. Biogenic sources, bioenergy is important. So bioenergy, electrification, take care of the markets. That's important. And the policies which bring these technologies into the market is that we have quite strict climate legislation. For instance, as Finland don't use much coal actually, so we have banned the use of coal, which represents about 10% of our energy, but have large emissions. But also having a very strong discussion with the stakeholders like industries, how to reach carbon neutrality. And this has been quite successful indeed. We speak also about a just transition because we have some regions in the country which will be losers. For instance, peat, which is like coal, we can't use in the future. There's a loss of jobs. how to compensate that with, for instance, new technologies and innovations will be important. So it's not just about technologies, but it's really about policies and looking on the whole picture and the whole society when we make this transition. Here's just some numbers about the Finnish energy transition by 2035, just to highlight that it really affects all the sectors. Primary energy has to be carbon-free, electricity and heat, and in particular heat is important in the northern part of Europe. I know that if, for instance, China, some parts you need a lot of heat, but also you would need thermal comfort, which is cooling. So heat and cooling, to look on that, because it's what affects our population, would be very important. How to decarbonize these sectors will be important. The most toughest part is transport. And in transport, indeed, we see that biofuels, in particular with the long-haul traffic that we have and transport, is important. So electric vehicles alone would not actually make the transition, but you need to really look on biofuels. And we look indeed on sustainable biofuels from residuals from our industries, or maybe also short rotation forest crops that we may have, where we have very, very, very short payback time for the CO2 footprint. So bioenergy comes indeed here in many parts, transport, and also, of course, in heating. In the whole Nordic area, Northern Europe, we think that half of the heating and future come from electricity, heat pumps, but the other part comes from bioenergy. So bioenergy will play the role of the fuel of the future, because we don't have coal anymore, there's no oil and gas. Those have been cut off from the energy system because of decarbonization. So the role of bioenergy as a balancing fuel becomes extremely important. So bioenergy is the fuel of the future, so to say, and we need to look carefully on it because it has so many multiple functions. Now just coming close to my final slides here, when we come close to decarbonization and carbon neutrality, there's also new issues that we raise. And one question is really the emissions from consumptions. So far, we have looked very often in world policies on the emissions of production. But we also bring to our imports. We bring emissions. We have outsourced those emissions to other countries, so to say. And we need to think slightly more about the consumption as well. And understand that some countries may have higher emissions because of our consumption. And in that sense, we need to maybe also to reframe the global climate policy slightly more, to understand that yes, we have consumption, which is also very important. Now, in case of consumption emissions from trade, for instance, in case of Finland, Denmark, or Sweden, the northern countries, it's about 50% of the production emissions. So it's a major part, actually, that comes from consumption. So Mr. Chairman, just wrapping up my talk to a few important points here is just to highlight the importance of few technology issues and technology possibilities that we have for decarbonization on a quick pace. Electrification of supply and energy use is definitely important. It is becoming a global policy. Energy efficiency is something that we shouldn't forget, because that's always the best way, I think, to proceed. It's sometimes very difficult in terms of the policies. Heating, cooling, that's a thermal comfort, and also the heat we need in the society. We see it's an important sector. It's a large sector. Half of all energy use, final energy use in Europe is actually thermal energy, and that's why we need to look on that. But also then take up on the agenda some systemic issues, systems questions. For instance, the sustainability of bioenergy in the future, because bioenergy plays an important role, but we need to look really on its sustainability more carefully. We need to look also on social impacts, and finally, as said before here, let's also have some more understanding about the consumption, that our emissions are also, we emit in other countries, so to say, because of our consumption. With these words, I thank you very much for your attention. Thank you, Mr. Chairman.
For your very illuminating and inspiring presentation. You mentioned different perspectives. First, the European, scenario on carbon neutrality, and so the points, for instance, like we need to use multiple approach to address the decarbonization, achieve decarbonization, like the sinks, of the swamps and the forests, and the both countries definitely is ahead of many regions in the world, and for different reasons. You mentioned the renewable. That reminds me the situation to learn on my trips to that part of the world, that you even use the geothermal, to achieve the renewable, and of course for the future, and you depict a very rosy picture, and in that situation. So again, that reminds me that we are in a global village, and Nordic countries are much ahead of the rest of the world. So we need to enhance the partnership collaborations to address the common challenge, the climate change. Some of the developing countries, really need a strong helping hand from those that accomplished a great deal. And of course, finally, you remind us, address the emissions from consumption by the countries in Nordic region. It's a very comprehensive, tons of information we gain. Thank you so much. And again, before I end, I want to thank you for the important bridging role you played, and particularly a more important role in the future. And with that, let's turn to the last speaker of this session. So Wei, a kind of, I can't say that Dr. Wei is a major figure in climate change study, but he is definitely a very important scientist in that area in China, and he's very busy, and he's not able to make it. And he asked his student, oh, probably not his student, and his collaborator, Sun Nannan, a professor from the same from the Shanghai Advanced Research Institute, the same research institute, and his field is carbon capture, usage and storage, to replace him and deliver that presentation on his behalf. So, Dr. Sun Nannan, please take the floor.
Okay, thank you very much. So, can you hear me?
Hear you, loud and sound.
Okay, that's good. So I guess my slides should be fine as well. Okay, so good afternoon, everyone. So I'm very sorry so that Professor Wei cannot take this event because there's an emergent meeting in the most of Science and Technology China. So I have to step in and take this part. So actually, I'm very glad to be here and to participate in this event accidentally. So I would like to give you a brief introduction on the development status and the research progress of CCUS and circumstances of carbon utilization. So, okay, I'm sorry. Okay, so the climate change is the major issue currently. So there's definitely a relationship between climate change and the anthropogenic CO2 emission. As you can see from this figure, that there's oscillation. There's the same oscillation of global temperature and the CO2 concentration in the atmosphere. But if you take a look at the recent years, we can see that the CO2 concentration in the air is actually increased far beyond the historic peak record. So we have to reduce the CO2 from the air. But if we take a look back to the last decade, we can see that the gap between the CO2 we need to reduce and what we've done is actually increasing. So in 2010, in that year, a prediction indicates that if we want to achieve the goal of climate change, we have to reduce 14% of CO2 in the future 10 years at that time. But last year, if we want to achieve the same climate change goal, we have to reduce 25% in the future 10 years. Okay, so that means the gap is becoming larger and larger. So we have to do more, but we are doing that too slow. So we have to find some new technologies for this purpose. So one of such technologies is the CO2 capture, utilization, and storage, always the CCUS. So actually, CCUS is a toolbox. Okay, it's not a single technology. So it's composed of several steps. So firstly, we have to capture CO2 from some sources, such as power plants, steel industries, or even directly from the air, and we transport that concentrated CO2 to somewhere. We can convert CO2, we can use the CO2, or we can inject the CO2 to some underground formations. So I will briefly introduce the general steps of the CCUS. So the first step is we capture CO2. So there are some options we can do. First, we can do, for example, we can do post-combustion capture. That means we can burn the fuels firstly, and we capture the generated CO2. Or we can do pre-combustion capture. That is, we convert the fuel firstly to hydrogen, and during this process, the CO2 will be generated, and we capture that CO2 because that CO2 is relatively of higher concentration. And also, we can do oxy-fuel. This is we first do the separation of air, and we obtain the pure oxygen, and we supply this pure oxygen to the combustion process, and we can achieve CO2 with very high concentration. And last is we capture CO2 directly from the air. So there are some pros and cons for different kind of technologies, but I think the most important technology currently is the post-combustion capture, because this is the most mature technology currently, and we can use this kind of technology directly to our energy system we're using now. And also the direct air capture, because this is a carbon negative capture technology. We can reduce directly. We can remove the CO2 from the air directly. That is very important, actually, if we want to achieve the carbon neutrality. It is expensive, yes, but it's very important to achieve carbon neutrality. And after we capture the CO2, what we do is one of the ways we can utilize the CO2 by chemically or biologically or geologically. So we can convert the CO2 to different fuels, chemicals, and materials, or we can use microalgae to convert CO2 also to fuels, fertilizers, or food, or we can inject CO2 to underground conditions. We can enhance the recovery of oil, gas, and even some minerals. So the importance of CO2 utilization is actually threefold. So firstly, we can reduce CO2, right? Because we're using CO2 directly, and sometimes in some cases, we can use the CO2 to substitute some carbon-intensive materials. So which means we're not going to, we do not need to use these materials. And also we can couple the CO2 reduction process with renewable energies, so we can close the carbon cycle for the energy sectors. That is clearly very important for CO2 reduction. And also we can take CO2 as the carbon and oxygen source. So by this way, we can achieve sustainable development, because in the future, if we want to achieve carbon neutrality, we can't rely on fossil fuels or fossil resources. So where's carbon from? So the best source is clearly CO2. So the potential of CO2 utilization is actually huge. The most important thing for CO2 utilization is that we shift the carbon flow from a lithosphere to atmosphere way, which we are using it now, to an atmosphere to atmosphere cycling way. So by doing that, we're actually avoiding the use of any fossil fuels and fossil resources. So we can reduce the CO2, because any of the fossil fuels or fossil resources we're using will end up as CO2, and we will release this kind of this CO2 into the atmosphere. So apart from the CO2 utilization, we can also storage the CO2 underground. We can to separate the CO2 from the atmosphere. For example, we can inject CO2 to sitting aquifers or depleted oil or gas reservoirs. the most important thing for CO2 storage is its huge capacity, because the CO2 we need to reduce is a very large amount. So we have to use this kind of technology to achieve significant CO2 reduction by CCUS. CCUS is actually will play an important role for carbon reduction. So according to the IEA, so if we want to achieve the 2-degree C scenario, CCUS will have to contribute roughly 70% of CO2 reduction among all kind of technologies, including renewables and technical electrification and hydrogen, everything. And if we want to achieve the 1.5-degree C scenario, CCUS will have to contribute roughly a quarter of CO2 reduction. So similar results was also reported by the IPCC. So in their estimation, if we want to achieve 2-degree C scenario, and so the cost to achieve this scenario will 38% higher if we're not using CCUS. So most of the developed countries paid a lot of attention on the development of CCUS technologies. They're costing a lot of money on the development of such technologies and related applications. These are some large-scale CCUS demonstration projects over the world. As you can see, the Boundary Dam in Canada is the world's first large-scale CCUS demonstrations, and it's running very well. And there are also some other demonstrations in different industries, for example, in chemical industries, steel industries, everything. And for China, CO2 reduction is a very important issue for us because we are the largest emitter in the world. So we have made our pledge to carbon neutrality. And in the past decades, actually, we also did some work in the CCUS area. These are some demonstrations in China, but as you can see, the scale of our demonstration is clearly smaller than the most advanced facilities. So next, I will briefly introduce some of our work on CCUS. We are the earliest teams in China working on CCUS. So in the past decades, we are now focusing almost all the CCUS chain, from fundamental to applications. So we have published some high qualified papers in this area, and we also have some technologies moved to demonstration or even close to the commercial use. So I will give you just some brief introductions, some examples of our work. So firstly, we are focusing on CO2 capture, and in this area, we are focusing on capturing CO2 by adsorption using solid materials. So in this technology, the material is very important. And what we do is we are focusing on 3 factors, that is process costs, process efficiency, and engineering feasibility of a material. So we're trying to optimize different kinds of performance of material, and we have developed our synthesis strategies. And currently, our carbon-based materials can achieve a CO2 absorption capacity of roughly 5% with a selectivity over nitrogen of higher than 400 at full gas conditions. So this is very high values. According to our estimation, we can achieve roughly 20% decrease in the energy consumption as compared to the most mature technologies, that is the amine scrubbing. We are also working on the large-scale production of the adsorbents. We're also focusing on how to do it on the engineering aspects, and also we did some works on small-scale demonstration. So we are looking forward to achieve even larger scale, maybe by the end of this year. And the second progress from our team is the chemical conversion of CO2 to different kinds of chemicals. So we have some examples. For example, the CO2 reforming of methane to syngas. So the importance of this process is that it can be coupled with the coal chemistry, because coal chemistry is very important for China. we are rich in coal, but we are poor in oil. So we have to develop coal chemistry. So this process can be perfectly coupled with the coal chemistry process, and we can reduce the CO2 emission, and we can produce useful products. The second one is the CO2 to methanol technology. This is a very most of the groups are focusing on this technology, on this process, and we are now we have achieved a demonstration on a 5,000 ton per year. This is currently this is the largest in the world. And recently we are also working on the electronic CO2 reduction, because this kind of technology can be directly coupled with the renewables. We can use some low-grade renewable electricity for the conversion of CO2, and we can achieve this process at normal temperatures, at room temperatures, and low pressures. So that means the conditions very mild. So the energy efficiency should be very high, higher than the thermal conversion process. We're also working on biological utilization of CO2. So this is mainly through the macroalgae. We developed our own algae seed bank in our laboratory. So these algae they work fine in real conditions, in real flue gas conditions, and we can achieve carbon reduction. And we use the products to improve the soil structure and permeability. So we can decrease the soil salinity, and we can fix nitrogen and increase the soil fertility. So we can achieve higher agricultural productions by using this macroalgae as a biological fertilizer. And this algae can also be used for the treatment of industrial wastewater. For example, in this slide we show that the wastewater from steel industry can be treated by our macroalgae, and we can reduce the COD, the total nitrogen content, the total phosphorus content, and the phenol content in the wastewater. So we can also grow the macroalgae and for downstream use during the process. Another case is we're also working on CO2 enhanced recovery of shale gas and shale oil. This because the shale gas and shale oil is very important unconventional gas and oil resources. So normally we do is we're using hydraulic fracturing to recover this kind of source, but this technology has great risk for the underground water resources. And for China, we have huge amounts of shale gas and shale oil, but we do not have enough water to do the hydraulic fracturing. But if you take a look at the distribution of the shale gas reservoir and CO2 emitter in China, we can see they are basically matched with each other. So this reminds us maybe we can use CO2 as a fracturing agent for the recovery of shale gas or shale oil. So what we do is we use some new methods, and we worked on the multi-scale mechanism of CO2 fracturing. So the general conclusion is that the CO2 works very well for the fracturing of shales. So it works very well to enhance the production of shale gas and oil. This because the diffusion of CO2 is far more better than water in the shales, which means we can achieve better fracturing effects, and we can achieve higher influenced volumes of the shales by using the same amount of fluids and the same amount of energy. So we can achieve better production, better enhanced production than water. We also conduct some field tests of this kind of technology, and we surely see we can see that the enhanced production is very well for such technology. And to summarize, because we think that CCUS is an important enabler for the sustainable use of carbon-based energy. Actually, for carbon neutrality, so even in carbon neutrality, the carbon-based energy is actually unavoidable, although the renewables will be very important. And also, CCUS is an inevitable choice for carbon reduction, and particularly the green recovery from the COVID-19. But actually, new technologies, new policies, and new commercial modes are urgently needed for further development of CCUS. It is still young technology. It is far from maturity. It will need help from factors other than technology. Okay, so many thanks for the opportunity to give this presentation. Okay, thank you very much.
Yeah, thank you, Professor Singh, for coming to see us out. And thank you for your excellent presentation. And you mentioned a few perspectives. One is that you place definitely a big hope on carbon capture and storage and utilization. And also you mentioned about the different strategies to achieve the CO2 utilization, to turn them to methanol, by microalgae to serve as a sink, to track carbon and store them underground. Also the enhanced recovery of shale gas, but impossible appears that due to limiting factor, water is a limiting factor for that one, and of course in your summary again, you gives a lot of hope on carbon capture and storage, but my past understanding is that they say that carbon capture storage doesn't have a chance because it takes years for you to really use it. That's a challenge. And if you can answer that question. Number second is that how far away? Oh, China has a very determined strategy to achieve a carbon peak by 2030 and carbon neutrality by 2060. How tough it is? Is there a very clear pathway so far? As a scientist, from your perspective.
These are very good questions. So, yes, currently CCUS is a focus from all over the world, but actually the cost of the technology is too high. One of the problems is that we do not have demonstrations. We do not have enough tests. But yes, it seems that CCUS will contribute less than renewable. But actually this relates to your second question. So how tough we can achieve carbon neutrality? Yes, it is very tough. It is very tough. There are some paths we have discussed, for example, renewable. But in the future, to achieve carbon neutrality, yes, renewables will have to contribute a lot, major role. But to achieve the energy safety, the national security, so the fossil fuel will have to play a backup. So in that case, if we want to achieve carbon neutrality, we cannot count on forests, grass and ocean to fully absorb all the CO2 emitted from the fossil fuels that we used at that time. So CCS will have to take a part in the future. So CCS, I don't think CCS will play a very important role for peaking these CO2, but it is very important for carbon neutrality. So that means CCS will boost, I think, around 2060 in China, I guess. Okay, thank you very much.
Thank you. All right. Okay, and in case we have one question from audience, please. Do we? All right. Since we don't have any questions, I want to thank all the speakers again for your excellent talks and presentations. And obviously that there are a lot of things that we need to further discuss. For instance, like the issue mentioned by the immediate past speaker, CCS does involves low issues, issues of uncertainty, for instance, that you store them, underground, then maybe a big earthquake in about 60 years. Who's going to take that responsibility. So things of that nature, we need to bring the social scientists, people involved law into the study. And of course, we need to learn the government decision makers of the potential pros and cons. So with that, I do want to thank all the speakers and all the audience. We'll get back in 10 minutes. In 10 minutes. Thank you. So next session will be chaired by our part-time staff, to a certain extent, not staff, I'm sorry, is a part-time advisor, a senior advisor to ANSO, Dr. Heaven from South Korea. Okay, get back.
Working in supply chain to manufacture, packaging, and transportation, and also import and export logistics. I hope you will give us great insight about how the Chinese can do green packing program successfully through this session. Let's welcome Mr. Yuan Liu, please.
Hello.
Mr. Yuan Liu, please continue.
Yes, let me share my screen. So could you see my screen?
Yes.
Okay. So good afternoon, everyone. I'm Yuan Liu, and now is leading the green packaging work in Thailand. I'm very glad to got this opportunity to talk about the green packaging work, since this is one of the most critical projects in Thailand and the whole Alibaba group. I think my topic will be a bit different, since this is from an enterprise point of view, to say that what we can see and what we are leading in this area. So I will share a bit about the background from Alibaba and Thailand, and the key things that we're doing in the green packaging area. I'm looking forward to the future communication and cooperation. So Cainiao is one of the company in Alibaba Group and is working on the logistics supply chain foundations. So as we know, the mission of Alibaba is to make it easy to do the business anywhere. And what it come to do is to, in the past 20 years, start to build up quite a lot of business groups to work in the different areas and have them a chance to go digitalization and realize the business growth. So from the chart below, we can see the bottom line is the foundation building. In the bottom line, we see the Cainiao is working on the logistics supply chain foundation, and besides it, there is Ali Cloud working on the technology and the system foundation. The Ant Financial is working on the payment and the financial service foundation. Dingding is working on the enterprise digital operation foundation, and Alibaba is working on the marketing and the digital management systems. So actually, these companies have already covered the major areas for the business operation foundation. On top of it, other companies working on the different channels to working on the retail business in different areas, in domestic and international. The familiar things that we can see is the Tmall and the Taobao working on the retails, Hema, Ele.me, and Koubei working on the local life, and we can see the Lazada and AliExpress in the international market. So as a set of this sector, this structure is the intent is to build up the business operation system. So in the end, the merchant could be very focused on the marketing work, and the business operation could be very easy. In the past 20 years, Alibaba has already grown up to include over 30 business groups, over 100 apps, and now that we have more touch points to the more users in different areas in life and business. And if we back to the logistic world, where Cainiao is working on, we can have a look at some high level numbers of the logistic market in China. In 2016, the number of average daily carrier households is over 84 million, and this number increased more than 100% in 3 years' time. and reached 170 million parcels in 2019. And from the data of the last year, it's already increased to 230 millions. Meanwhile, the cargo of China's cross-border parcel grows with 30%. This number can show us that the China's logistics market is growing very fast, and this 5 to 10 years is the best period of the rapid development. So when we deep dive into the industry, we think the package, carrier, the hub, and the vehicle are the most important components that can be digitalized. We believe the traditional way of working will transform to the new generation of digital solutions, such as in the packaging area, either from the e-shipping label to the next generation digital solutions. It will from the traditional PDA to the novel digital device. It will from the automated equipment in the large sorting hubs to the equipment adoption in the smaller hubs, and from the vehicle GPS to what we can see as the advanced driver assistance systems and the driverless vehicles. So actually in the 8 years time, in the 8 years time, Cainiao has defined 3 different customers: the consumer as a customer, the merchants as a customer, and the logistic partners as our customers. Cainiao has also launched 5 business units to serve the different customer types to different types. To the consumers, we have the Cainiao Posts, which is the digitalized community service centers. And nowadays that we have built up more than 113,000 of China Posts. And Cainiao Gogo is a crowdsourcing parcel delivery platform. And to the merchants, the domestic supply chain is working on the omni-channel supply chain solution to brands and large merchants, and exploring the cloud fulfillment to the industry belts. The global supply chain is building up the global parcel network and global freight network. And to the logistic partners, we build up the logistic parks, which includes the e-hubs for the overseas network, the warehouse for the domestic network, and the industry parks for the industry belts. And the logistic technology is working on the leading edge technology to drive the innovations, including the IoT, digitalization, unmanned vehicles, and automation solutions. And actually from the 2016, is the first time China come to claim the green strategy as one of the main direction on our business growth and the technology development. And in the past years, we keep on to exploring and develop the capability in different points. And now that we start to connect is the end-to-end whole chain capability for the green logistics. From the chart, from the right side to left side, we can see in the green park, we now have the photovoltaic power generation. In the warehousing park, based on the data technology, we have packing algorithms which can reach to the leading case fill rates in the industry. And we have the SIOC package, which means that we directly ship the original shipper to the consumer with no repacking. And for the shipper reuse, which means that normally the original shipper to the warehouse will be scrapped, but we will to match it with the parcel used as the parcel box. And the e-shipping label actually every year will save up to 100 billion pieces of papers every year. And in the packaging areas, we have a set of the green packaging solutions, including the plastic-free package, the reducing package, and now based on the different feature of the customers, we can have the customization packaging to serve for the green needs. In the transportation part, while increasing the scope for the new energy vehicle, and based on the data technology, we now have the smart inventory allocation and smart route planning to effectively reduce the distance and to reduce the carbon emission. And at the end part, we now have more than 113 posts, which is close to our consumer. And we have set up the recycling bin at every post to receive the parcel materials and to put it into the recycling loop. And to the consumer, we have a program which is called Cainiao Ocean, which is to educate the consumer for all the green things that we're doing through the loop, and we try to attract more consumers to join the green shopping and to join the green environmental protection activities. Actually, that we have set up a green shopping mall on our Cainiao app, and all the products in the app and in the mart is using the green package. So if the consumer is intentionally to choose the product with the green package, we will give a green energy to this consumer, and with this energy, they can donate into the social welfare activities. So with this way that we try to build a total chain from the green logistics to the society education as a closed loop. If we zoom into the packaging work, we are based on the principle of the 3R1D to build all these of actions to drive for the net zero and reduce the non-degradable plastic. And the way is that we want to invest more on the base capability building and to be more open to cooperate with our customers and partners to co-build the supply chain capability. Since Cainiao, the future is that we are kind of a platform company. So we think the most strength of us is to be more open and to have more collaborative clashing and cooperation with other partners with us to maximize the scope of the green activities. So if we go through the details of every action, digitalization is the strength in Cainiao, and we are using that to drive the reducing packaging. We have the patent in the algorithm of the box design, and now that the case fill rate is over 60% in Cainiao, and this is leading in the industry. And for the packing area, we have a patent in the 3D bin boxing algorithm. So as we know that in the traditional company of the logistic warehouse, the operator or every operation station is the only one to choose that which is the box type to use for the different orders. But in Cainiao, we try to make it as a standard way. For every order structure, it will go through the algorithm to calculate that which is the right size of the box to be used. And the message will transfer to every operation station in every warehouse. We have installed a screen for every operation station, and from the screen, the operator can easily to read that which box he need to choose for this order. And this will help us to maximize the case fill rate in every single point. And for the packaging solutions, the traditional way is that we will to define the standard in offline SOP or standard and to train the operators how to pack it. And in the end, the operator will be the one to decide that if the product need to be protected or not, and how to protect it. So the quality will be very different based on the different experience of the operators. But last year, we started to build a technical solution is to make it online for the fit for use packaging solutions. For every single product coming to our warehouse, we'll give a digital label to it to describe the dimension, the weight, and the original package type, like it's a bottle or paper or shipper, this kind of data. And all this data will go through the algorithm to calculate that if we need to protect it or how much we need to protect it. And all the results in the same approach will pass to every single screen on the operation station to guide the operator to make the packaging work. So with all these things, this is to maximize the standardization to help us to avoid the over packaging or over damaging in the logistical way. And for emission label that we have a shipping label, we have introduced it. Cainiao is the first company to invent it. And with that, we can reduce the shipping label from 5 pieces to single pieces. And the effect is that in the past 6 years, we have received over 400 billion pieces of papers. And in the other way is that we will leverage the packaging solution to realize the touchless supply chain. The first thing is a shipping on container. This means we are cooperating with our merchants to develop the package. The package could when from the point it is sending out from the manufacturing plant to consumer, we don't need to do any repacking on it. This is no-touch design. And the second is the ECP product. This means the enhanced commodity package. This is more for the high damage rate products. For example, like the rice pack. The rice is always in the top 2 damage rate products. And in the downstream, in the logistics supply chain, we will need to do a lot of protection and repacking work to protect it. But damage rate is still very high. So our approach is go to upstream to redesign the package for the rice. So we have got the patent for this area is that with a similar cost, but with a double the strength on this package. So with it, we can ship it with the original package to our consumer and at a very low damage rate. And the third part is for the RFID embedded package. With it, that we can realize the supply chain control and to largely enhance the productivity in the downstream supply chain. And for the non-degradable plastic, first is for the plastic-free box design. We now have got our intent for the box design. With it, we can largely enhance the open box experience. And when we open it, I'm sorry, I cannot show you a real box, but if we open it, that we can see we got more space for the product claim. And even the cost is 5 or 10% lower than our traditional Z box. And we have a set of solutions developed for the biodegradable plastic bag and the green materials to release the plastic we traditionally used in the packaging work. And for the reuse and recycle program, since we fully believe that the recycle is an extreme status for the reducing packaging solutions. Since in the end, that no material will be consumed. We have no plastic and even no paper. So we now are increasing the scope in both the 2B channel and 2C channel for the recycling box. And the third one, as we have mentioned, is that we are using the original box to the parcel usage, which means normally the brand manufacturing plant, we're shipping the product to the warehouse. Your case count is around 12 bottles or 24 bottles. But when the consumer to place order, it's only 1 or 2 bottles. So we will need to depack original pack and the package will be scrapped. And then we will use a new box to make the parcel and deliver to the consumer. This is a big waste. And now that we come to reuse the original box for the big size of the parcel delivery. This has saved around half of the shipper usage. And the last part is for the recycling bin. As we mentioned, we now have built up more than 113,000 of the Cainiao posts. And in every post, we have setting up the recycling bin to receive the parcel materials. So this is to making a closed loop for the material usage. And another important area is about the quantitative management. Since currently the LCA and accounting work is not so mature in the logistic industry. So what we plan to do is that we'll come to build a platform to help us to quantify the carbon footprint in the different packaging solutions. And we will even put a QR code on every product so the consumer can easily to scan and to understand the footprint of the product, to understand the carbon emission for different packaging solutions. Based on that we can find the key points where to improve the packaging, to reduce the emission, and also that we will use that to help our customers to choose the packaging solution with lower carbon emission. And at the end, which we see is even more important is for the community engagement. Since for a single enterprise can do is very limited. So we would like to leverage our platform attributes to engage more consumer and more customers to do the green activity together. So this is a loop for what we do at the consumer side. So as we have mentioned, we have building up the online shopping mart for the green product with a green package. So if the consumer come to order product from this shopping mart, we can see on the second chart, the second screen is that we will to visualize it in our logistic details page, which is to mean that there's a green parcel come to you. And if we click on the banner, it will link to the package for the consumer to gain the green energy. This is to recognize the consumer behavior. And on the fourth screen, we can see we still have we have also built up the mobile game for the consumer to gain more green energy. And another screen is that the consumer can use the green energy to donate to the environmental protection activities. So this is a loop to engage more consumers to join this activity and also to encourage our customer to design the packaging in a more green way. And actually, around two days ago, we have just conducted the global smart logistics summit. And in this summit, we have published that we will have the China green supply chain plan. A key action is to build up the 2B recycling box standard. The recycling box standard is not a new word, but in past years, we have many brands, many channels, and many suppliers have tried to make it. But in the end, that we will face the same problem is that we cannot scale it up. We have two pain points. The first is that we have too many box types and it cannot be shared across the brand. So in the FMCG industry, actually a middle-sized company will have over 1,000 of the package the shipper types. So if the company decide to use the recycling box, that transformation will be a big work. And if many brands want to use the recycling box for the store, who need to face many brands, it will be a huge complexity in the box management. And too many number of the box will still leading to a low turnaround rate. On the other hand, is that the channel adoption. If only China want to use the recycling box, but this is not accepted on the other channel, it will be a high complexity to the manufacturing plant. Since the plant will need to differentiate the packaging even for the same SKU at very sourcing point. And this will stop the plant from the automation usage. So all these points will finally lead to the high cost at every point through the supply chain and a low turnaround rate. This is a key point why the recycling box cannot be scaling up in China and maybe in the world. So what we tend to do is to leverage the big data resource and the data technology in China to design the common standard for the box design, and also to engage more channel players and brands to have a society sharing for the recycling box. So in the end, that we can reach the breakthrough of the scope increasement. From the left side, that we can see we have gathered the full data for the products in our product center. Based on the algorithm analysis, that we can use limited package number to cover to find a sweet point between the volume coverage and the case fill rate. For example, in the personal washing industry, we can use only 13 package type to cover around 60% of the volume and to reach 90% of case fill rate. And we try to further increase the volume coverage. We can use 19 case number to cover around 70% volume coverage. So if we want to further increase the volume coverage, the more case number will be needed to sustain the case fill rate. We now have a deep study in the impact from the case number to the whole chain turnaround rate. And based on the balance, we to design the results. The second part is for the channel application. we know we will to get through all the channels in Alibaba Group to ensure in the end, we can have a base scope for the cross-channel usage. And based on that, we will be very active and open to the channels which is out of the Alibaba Group to use the same standard. Since we fully believe only in the way of the society sharing, we can maximize the usage of the recycling box. And the third part is that we will apply the 菜鸟 RFID in our recycling box, which is to enabling us can have the digital management for the circulation system. The feature of the 菜鸟 RFID is that it can go through the metal and liquid. This is very important for the FMCG industry. And based on that, we will to have the connection between the goods and the recycling box, and also have the connection between the recycling box and the car and the truck. So based on that, we can realize the digital management through the whole supply chain for the goods level. This will be a real breakthrough in the digital management area. So what we try to do is actually we want to be more open and to cooperate with all the brands, the channels, and the suppliers to co-build the standard in these three areas. And in the end, that we can realize the social sharing in this area, and we can realize the breakthrough in the scope increasing of the recycling box. So these are all the things that I come to share here. Thank you.
Thank you very much for your wonderful presentation. I have just a couple of questions. First thing is about the recycling bin. It's a very wonderful idea to have a more than 130,000 posts, especially maybe around all area in China. But is it enough to cover up a certain very dense city area? This is first question. And the second question is, you also talk about $2 billion for reuse. What about the percentage of total boxes used by many Chinese companies? Two questions. First, the 130, post is pretty good for covering dense city area. And second thing is percentage of reuse box.
So let me repeat your question. Is that for the recycling box, if we can cover more areas in China?
Yes, in China area, yes.
Yes, for sure. Actually, I think the ideal state is not that we can cover 100% of the volume in China, or if we can cover 100% of the SKU here. So this is really how we can find the sweet point between the volume coverage and the case failure rate. Since that we know currently the pain point is that we have too many box sizes to realize the purpose, but that will lead to a high cost and a low turnaround rate. So now the first point is that we need to reduce the box sizes. So that's why that we want to limit that within 100 to maximize the turnaround rate. And now, based on that, we need to find the sweet point. Is that firstly that we want to cover the major volume of the major SKU in every industry, and the second that we don't want to lose the case failure rate, since that will lead to the air transportation in the truck. So what we plan to do is that we will cover around 60% or 70% of volume, and on the other hand, we'll come to engage the companies and the brands to design their products to fit in the size. So with two directions, we can finally to further increase the volume coverage with no loss on the case failure rate.
All right, so one more question about the role and mission by Chinese for the world, or just for in the framework of Asian country. Is there any leadership for Chinese to make any digital like a format globally could be used? For instance, like digital standardization I know the Chinese actually cover more than half of a global parcel volume and annually. Then if China can take a certain leadership for standardization, is it possible to do with many other countries, like leading countries like the US and Europe? Then they can participate, like what ANSO is working for. Can you answer to me from your opinion? Standardization,
Actually,
cooperation, yes.
yes. Actually, based on my feeling is that firstly that e-commerce business scope is very large in China, and currently in American and Europe, the scope is not so high at this moment. And as we know that Asia is a major area for the business e-commerce business growth, and as we can see, the speed is higher in Korea and China, and the scope is in China, the scope is much bigger. So what we can do here, I think, is to building the pilot and to building the capability. And I think that when the American and Europe come to a level of the scope, that will be the capability could be reused.
Okay. Well,
and
thank
for
you.
Alibaba, now that is the go global and go international is one of the major direction here. So as you can see, actually now that we are come to cover more scope in the overseas area for the Alipay and for Tmall and for the AliExpress. So there's some channel that will come to expand the digitalization capability. And I think that in future we can have a way to extend the scope coverage.
Okay, thank you. Is there any question from audience? If not, thank you very much for your wonderful presentation. Let's move to the next presentation. Next presentation will be by Mr. Yeah, what's his pronunciation at Tefsai Shupniti, Director of an AI Research Group. So his experience is related to the type of data on the collaboration and local community with the 5 steps for the implementation, especially collection, digitalization, management, and the connection and utilization. Let's welcome next speaker.
Thank you so much. Okay, then I start to share my screen first. Okay. Okay, hello everyone. Thank you so much to inviting me to join this session. This is title of my work today. Okay. As you know that in Thailand, try to. Okay. In Thailand, the culture and biodiversity has very important. And let me show you this one. When we see about the museum in Thailand, we can see that the growth of them is quite a lot when compared to the previous. And mostly it's not the government related, but it's some kind like a private and local community museum. Then in terms of culture, if we start from the local community, it's quite important. And at the same time, when we consider at the biodiversity, we can find that Thailand is also quite in the higher position that have a risk of biodiversity. Based on these two things, it is important to do something on this work. Then by using this one, our motivation is try to both culture and we think that culture and biodiversity is an important asset of Thailand, and local community have their unique culture and biodiversity. And for the biodiversity rich area, the culture closely related to biodiversity. Then we can merge both of them very easily. Then the objective of this work is try to preserve cultural heritage and biodiversity through digital media and content, and try to increasing recognition of digital preservation and biodiversity recognition, and make a collaborative network among communities for digital preservation and biodiversity, and enhancing the utilization of data for local community, such as tourism, business, and so on. And what we aim is to start to collect cultural diversity and biodiversity, and try to do both in terms of preservation and innovation. And the area that we aim to work will be like education, tourism, innovation, and creative economy. And let me show you a little bit about the project history. Actually, this project is like 10 years before. It starts from, we try to develop some kind of like archive for management system. And after that, we get some collaboration with the Ministry of Education and change to be cultural management system. And after that, we think that we need to extend to other locals. Then we develop the platform that we call the UNRAC platform, based on like Thailand Research Fund and others banking and Royal Society. And nowadays it's moved to our current work that we call Nawanurak platform. This one, we start from the culture, but from now on, we mix between the culture and biodiversity. And this is the framework of our platform. They are composed of 4 components. Okay, this one we collect the data from the local community, and the first component is about the e-culture service platform. There are a lot of things. For example, cultural archive, cultural watch, cultural attraction, and cultural route. That all try to collect the archive and try to see whether they have some missing in terms of culture and biodiversity or not. And after that, we develop culture bank, cultural and the biodiversity bank that have a lot of assets like artifact, cultural person, attraction, traditional, and bio. And in terms of what text, pictures, video, and 3D. And the highlight of the research in this part will be the cultural and biodiversity heritage analytics platform, because we gain a lot of information, both culture and biodiversity. Then we apply like a knowledge graph, knowledge extraction, and also when we launch this kind of thing to people can look and see. Then we can gain the user behavior. And the fourth one is Nawanulak Playground platform. This one, we think the collection of information like text, pictures, video, and 3D is like a primary asset. But we can add on many things that, for example, we can develop like virtual reality, we can develop hologram, we can develop quiz, and so on. Then when the people go to the local community and try to understand them, sometimes local community have not much people to organize. Then by using technology that can help the people who join in that community can gain a lot of knowledge without the people help, by using the technology instead. And all the data, what we aim is that we aim to develop data in terms of open data, and we provide the API in order to have a lot of people to make use of them. Then people can have a lot of application by using this kind of data. And at the same time, we can join with national external archive or international external archive, because we try to follow the international standard of using the collecting data. This is the digitization process. It starts off from collecting, digitizing, and data management, data integration, analysis, visualization, and this is the like a final goal is the cultural diversity and biodiversity link open data. This is some kind of like the scenario that we try to go some place in the local and try to give the training to them, and then people can get the lecture and they can develop their own asset by themselves. And after that, you can see like a small children they can do this thing too. this is like they try to collect everything in their own area, and after that they try to digitize them. Okay, and this is the part that we can digitize them, and after that, after digitize, then we can get data management. The metadata standard, for example, in terms of cultural, we have like a CDWA and ISAT, and also for the cultural diversity, we follow the Darwin Code. This is some kind of like a data management. This kind of thing that like a very easy tool in order to make the people in the local can use. Then the key point is that we need to make it like a for the non-IT people. Okay, and when manage with and make some kind like a museum and try to link data together. Okay, and there are three types of platform that we are developed. The first one is the cultural diversity management platform. We have the back-end system that people can easily log in and try to collect or digitize data based on their own, and we also get them the statistic of data, because they can categorize the type of the data by their own, because each local community have their own content, and they can display the local culture like this. They have many types like an ancient document, archives, and so on. And also they can use like a QR code, quiz, questionnaire, something like that, in order to make use of them for the people who come to use, and then we can get the user statistic. For the biodiversity is also similar, but the main point is that we collect the biodiversity data. Okay, and also we can use QR quiz questionnaire and use statistic on this. And for the tourism and product management platform, we also apply this one and try to make use of them by we have the back end for tourism and culture, and then they can make use of this by compose with the data that they collect and try to make the attraction and route, and then by the local. As you see, normally like a tourist community, they try in the tour community or company, they try to make a lot of route. But this kind of thing we want to pay attention to the local, what they go and what they see, because sometimes for the tourists, they want to dig inside what the local people go and what the local people look, things like that. And also we also have the like a part of product, because in a lot of local community they also have their own product that is quite very nice. Then we put this kind of thing in our collection data and also link to the marketplace in Thailand. And this is a summarize of our community now. Currently, we have around 14,000 assets with nearly 88 organizations who join together in like a 15 province. And in the end of this year, it will be like a 24 or 5, something like that, from 77. Okay. And this is I want to show you. This is the people who use this platform. For example, in terms of organization, the Thai Red Cross Society, they try to collect like a historical information, and administrative court also collect a lot of information. And Navi Museum and Royal Society, they also try to collect a lot of archive there. And this is some kind of the local community. For example, the first one is Koket is one like a local community in the local nearby Thailand, and they have a very keen in terms of like pottery. Then they have a lot of some kind of like the way to develop pottery and the pottery types, something like that. And the second one is some kind of like the place in Chiang Mai. We have the place that try to make the umbrella, and you can see they have the like a umbrella material, the way to produce the material, the style of umbrella, and so on. And the light one is some others local community that have like a products, their own products in terms of process, and have the unique. They use the local plants in order to develop their own style of their processed product. And for the biodiversity, we also have like this one. We have a geopark in a stone area. Okay, that they try to collect a lot of picture about a lot of animal in stone geopark. And also Savannah University also try to collect a lot of plants around nearby. Then we have also this kind of thing too. And in order to do like this, we also have other technology transfer and activities. For example, we have training course, both online and on-site. We have hackathon, and we have currently we try to develop some kind like a story creator challenge, because in each local community, they have their own story, not only the material, not only the biodiversity object, but also the story is quite important. Then we try to help them to understand how to create a story. And other users is something like we can provide this one, and there are some group that try to develop some kind like a tourism application. Some group try to make use of them by develop the AR object, and they use them to develop the QR board, and make use of them by develop some kind like hologram and 3D model printing. And this is also some kind like make use of them and develop the hologram. I can show you the scenery of this. Okay, can see this. Okay. This is this is the imagination of the in the geopark, and they try to image of the bat, some specific bat type in our geopark area. Okay. This one they use a hologram. And another one, the way to apply this kind of collecting data is to develop a museum. When we go to the museum, especially in the local community, sometimes we do not have people to explain to you, and sometimes the information is in the paper base. And if you want to use the application, sometimes they have a lot of in some area they have their own application, and you have to download a lot of application. Okay, and also lack of guide and staff. Then what we do is that we try to develop the virtual museum that help for the on-site and also the off-site. That other countries also have this kind of thing already. But in Thailand, we also develop one platform that we call the museum pool that try to gather a lot of museum all together. Okay, then in terms of off-site or online, then you can see in your mobile phone about in each museum, and you can get information like what is in the museum, what is in the content, and have some inside information. I'm so sorry that it's in Thai. Okay, and also on site they have some kind of like a QR code, and then you can use your mobile phone in order to read the QR code and then show to you in terms of text or video and something like that. That is important information to you. Okay, and we also run this kind of thing in not only in Thailand. We also have collaboration with Yangon in Myanmar, and they already put the museum pool in Myanmar. And also we talking with Bagan, this is in Indonesia, and then we also have this kind of thing in Indonesia too. And also another thing is that we also visit Luang Prabang, this is in Laos. Then in this area we also have this kind of museum pool altogether. Okay, I think this is overall of this kind of platform that you can see how to collect data and how to make use of them. And we also have a lot of things. For example, we want to mix up between cultural and biodiversity, big data, and open data. And also we try to make use of them by convince people to do the storytelling. This is very important part. And also try to connecting between culture and biodiversity. and try to make use of the playground by put the visual reality in each local communities, and also integrate with the other resources. I think this is all of my topics now. Thank you so much.
All right, thank you very much for a very interesting presentation. Just I have one or two questions, especially digitalization process for museum poll platform. So maybe more than 20 museums participate in this program, right, in Thailand?
Yes.
What is your timeline, like a phase line for the completion or partial completion of digitalization supported by the government or together with local government? Do you have any phased diagram? How many years it takes?
Actually, it's a good question. Okay. Actually, there are two steps. The first one is to collect the data, right? To collect the data, we use Navanula platform. Currently, we have one project in the Ministry of Higher Education, Science and Innovation, and try to make use of them by bring the communities to put the information into Navanula platform. Currently, there are like around 30 or 40 players that already done this. And also, we also have another project that we have more than 10 provinces that join together to put the data here. And based on this, we can link to the museum pool, and then all the area can have the a museum information. But in terms of overall, like a local community, they have various types. Then in order to select the local community is not easy, because in some local community there still lack of the people who try to understand the technology and some kind like this. Then what the aim is that after we finish the phase to extend to like a 10 more province and university project, and then we try to have the bigger project in order to put in the term of the country level. Okay.
All right, thank you. One final question. Do you have any extra funding resources? Might be like from the World Bank or UNESCO or Chinese, any funding sources?
Good question. Actually, we try to approach for some nearby area, for example, like Lan Chang Mae Khong. We also try to approach too, and also there are some area like Korea and Japan that have something similar to this, and in Southeast Asia. But in terms of like a UNESCO, it's something like we do not put this kind of thing into UNESCO level, but in each area. For example, Stone Geopark, they aim to be the UNESCO level. Then they need some kind of technology to help them. Then based on this kind of thing, local community try to get the funding from their own, and then ask me to help.
Well, thank you very much. I hope you have a great success for this wonderful progress.
Thank you so much.
Thank you
We still
so
need a lot
much.
of help from many people in order to make this one quite successful. Not only in Thailand, but in also a nearby area too. Okay.
Are there any questions from audience? If not, thank you so much again. We have the last speaker, Mr. Liang Dechi from Architecture of a Quiet Cloud, Enterprise Intelligence. His talk will be related to Huawei empowering the protection of a green home. He has a good experience in many different areas, especially currently is focused on the implementation of Huawei EI solution in the Asia Pacific region. And also during the tenure at Huawei, he was assigned to WEU to be responsible for the local cloud business development. Let's have a speaker, Mr. Liang Tachi.
Good afternoon.
Good afternoon.
Yeah, good afternoon. Yeah, you may call me Edwin. Yeah, so I'm going to share my screen.
Yes, quick.
Are you able to see my screen?
Not yet. Right.
Okay. I'll put it in projection mode. So, good afternoon, everyone. Thank you for having me into this session. It's my pleasure today to be able to meet with all the experts and audience online and exchange the ideas and practices we are doing in artificial intelligence for the green society. I'm currently working in Huawei Cloud Enterprise Intelligence Department. This department, the goal of our department is to help our customers to implement the AI and the big data technology into application. As computing and 5G communication capabilities are greatly improved, the AI technologies have been through the exploration phase of applications. It has been using as a new general purpose technology to achieve the collaboration with the social environment and promote development. Actually, AI is entering into core production systems of enterprise and creating great value. According to our research, the AI adoption rate by 2025 will be as high as 86%, and it will be gradually applied in various industries, including public, education, health, media, pharmacy, logistics, and finance, etc. And from our project experience and observations, there are three major technical trends of AI, and I would like to share with you. The first one is from perception to connection. During the pandemic last year, actually, the Huawei Cloud AI team, we extract the knowledge from newly published academic literatures and expresses it in the form of knowledge graph. This is the first knowledge graph that includes entities such as drugs, diseases, and viral proteins about the COVID-19, which helps us understand more about the virus and take protective measures. The second trend is from single modality to multimodality. Take the most widely used AI technology, OCR, as an example. Nowadays, our customers have higher expectations not only to convert a scanned document into digitalization, but to truly understand the content in the document in order to make quicker decisions. This is why we see OCR is usually combined with NLP today. The third trend is from cloud to cloud device synergy. Benefit from the limited computing power in the cloud. We can train and tune an AI model much faster than before. But in real-time information processing, in order to have lower latency and better user experience, the prediction often happens in the device. It requires the cloud and the devices to be able to sync with each other in the same framework. And Huawei, we as a global ICT company, we have deployed globally and built computing power, algorithms, and data as our core competitiveness. We have established multiple R&D centers in Asia, Europe, North America, and North Africa. We also cooperate with more than 85 global institutions partners. At the same time, we are committed to contribute our technology to the community in order to build inclusive AI capabilities. Speaking of AI research, we believe the three core values are empowering developers, driving AI-powered business transformation, and cultivating talent. We will continue to invest around these 3 points to leverage our strengths. Here are some of our academic publications in prestigious international AI conference. As mentioned, we focus not only on perception, but also connection. In the past, industrial AI project practices, Huawei Cloud's AI capabilities have been refined and forged. and achieved outstanding results in several top international competitions, including #1 in ImageNet classification, WSDM #1 in knowledge graph and data mining, etc. In this page is the overview of our Huawei Cloud Enterprise Intelligence Services, in which we apply our full stack, full scenario AI strategy. We provide more than 70 services and 180 functions, building the fastest growing inclusive AI platform. The basic platform service provides excellent AI experience based on the data and the AI development platform. Currently, the model training and inference speed will have the world's fastest record. And the API layer, we provide rich services with excellent performance. Common APIs are ready to use and are integrated by industrial systems. In data integration with industry intelligence, we provide integrated solutions and directly enable industry intelligence upgrade. And the Model Arts, it is our one-stop AI development platform, which can be used by AI developers of all different levels. It has 5 main features, which are ultimate computing power, high cost effectiveness, efficient implementation, unified operation and maintenance, open and sharing. To better support enterprise-level AI and research and development, Model Arts is optimized in terms of cluster management scale, number of supported tasks, and large-scale distributed training. The Model Arts R&D platform can manage tens of thousands of nodes and better meet the training task requirements of large enterprises and governments. With the optimized service framework, Model Arts supports concurrent running of 100,000 enterprise tasks and concurrent use of 100,000 users. For large-scale and complex training tasks, it provides ultra-high, large-scale distributed capabilities. An excellent distributed acceleration ratio is the key capability of large-scale cluster distributed training, and is also the key factor for users to select the clusters to accelerate our AI services. And before we can implement all these technologies mentioned and platforms mentioned above to our green society, we have to make sure the technology itself is environmental friendly. So we applied the so-called eye-cooling AI algorithms in the data centers we built across the world. By collecting more than 60 parameters, such as cooling station, precision, air conditioner, load, etc., in the real time, we are able to perform an AI-controlled energy-saving algorithm to greatly reduce the water chiller loss and saving energy. In one of our biggest data center located in Langfang, as shown here in the picture, the eye cooling improves system energy efficiency by more than 50%. And starting from this page, I will talk about our real use cases in the green society. The first one is we collaborate with the Rainforest Alliance. It uses Huawei old smartphones and self-developed solar charging devices to monitor and analyze the sound data in real time with the Huawei Cloud Model Arts. In this way, the endangered species of tropical rainforests, such as spider monkeys, as shown in this picture, are safeguarded. I'll talk more about this solution. Actually, Tokarai, the founder of Rainforest Organization, uses the recycled Huawei mobile phones to create a rainforest guardian to receive data, sound data, real time around the clock. And we can accurately identify the sounds of chainsaws and trucks and send alerts to the foreign guides in real time. This AI technology will also help interpret more behavioral information about the spider monkeys. We believe that The technologies makes the world a better place and builds a harmonious ecosystem. The next case is about the combination of remote sensing technology and AI. Remote sensing technology provides a more scientific method for people to observe the Earth objects and understand the world. At present, this technology has played a vital role in addressing climate change, disaster prevention and mitigation, agriculture, and forestry. With the ever-expanding application of remote sensing satellite data in various fields of social production and life, it is the future of remote sensing industrialization to open and share data, combine data with various industries, explore brand new business models, and build industrial ecology. However, the huge amount of satellite data growing at PB level every day, the model training that consumes a lot of resources, the security and the cost problems will also bring challenges to the industrialization of remote sensing industry. In addition, the fast processing capability of massive remote sensing image data is insufficient, and the data usage efficiency is not so high, which also imposes higher requirements on the process of data storage, processing, analysis, and distribution, which affects the efficiency of remote sensing image usage and spatial decision making to a certain extent. And Huawei Cloud GeoGenius is then built to address all these challenges. By leveraging our AI and big data capabilities, we are able to fully implement the remote sensing technology and combine it with AI and computer vision, such as this kind of AI technologies, to be able to address the environmental change, climate change, and monitor our land and identify any buildings that is not illegal and harmful to the environment. And the next few pages, let's look about the cases that more related to our daily life. As shown here in the middle, it is actually a map of our Shenzhen Longgang district. It is a district within the Shenzhen city, which is the headquarters of Huawei, and it has more than 5 million citizens. And we combine this traffic, water, and heating in different ways to improve our residents' satisfaction and also protect the environment at the same time. It liberates every dimension in the next few pages. The first one is the traffic goal. By improving these eco-friendliness and intelligence of transportation, we are able to not only just monitor the real-time traffic conjunctions, but also we can control the traffic lights based on the real-time traffic situation. And by doing this, we will be able to save more than 3 million car minutes every year. You can imagine how many carbon dioxide we will be able to reduce. And here are two examples shown. One is in the Tianjin city, and the other one is the Shenzhen city. From the picture, you can see before using this technology, it has a very huge traffic. But after that, the traffic, the road is clear. And the rush hour has been reduced by 10 to 15 minutes every day. And the second one is the water goal. It is our Huawei Cloud services that improve the water cleanliness and making water management more intelligent. Here is an example in the Suzhou Binjiang River. The challenges is we don't have enough manpower to inspect the river at the same time, and also because, especially at night, it will be also a challenge. But by using the cameras and the computer vision technologies, we will be able to monitor these water conditions in a real time and 70 by 24 hours. With the higher than 80% accuracies, we'll be able to detect the floating debris, the drainage outlets monitoring, and also the water level alarm, etc. And the next one is the heating goal. We all know that China is a big country, and especially in the northern city, in the winter, the temperature is very low. So we offer the centralized heating system to all the citizens, and we collect all the data from the climate model, and also as well as the real-time sensors which have been built in the building of the citizens. Then we combine all these parameters together. We will be able to use our AI algorithms to forecast and analyze the best way of tuning the temperatures. By this AI-powered network-wide balance and optimization and control the temperature. And it will also help us to save a lot of energy, but also improve our residents' satisfaction. And at the end, I want to emphasize again the importance of calibrating talents, because protect the environment, it cannot be done by a single company or a single country. We have to leverage together, work together to build a better place. So this is the end of my sharing. Thank you.
Especially the last slide, cultivating talent. So we need a kind of a manpower for the future and also contributing themselves for the world. Especially Huawei is doing good for China and the rest of the world. So how are you gonna have a good program for cultivating good talent, whom they can work for the world and the China too? Do you have any special program in Huawei, especially cultivating talent program? Hello, Edwin?
Oh, yeah. It is
Edwin, do you
your
hear
sound
me?
is very low. Yeah.
Oh.
I can barely hear you.
I'm sorry, kind of
Okay.
technical problems. Okay, let me just, because of
Yeah,
time
sorry,
limit, I
I
have just one quick question about the last slide.
Mhm.
Do you have any special talent program for cultivating people for the world and also for China?
Yes, yes. We have all these different programs for not only the developers in China, but also for the world. We have this AI. We'll be able all the developers from all over the world will be able to join. We provide such as some classes and also the some campaigns and competitions. We encourage every one of you to join us.
Well, thank you very much. Are there any questions from audience?
So I am quite interested in your AI talent cultivation project too. since in Thailand, we also launched one project that we call AI Super Engineer, that we try to collect a lot of people who are interested in AI and try to give them a knowledge of AI. Then maybe we'd like to learn from you later.
Yeah, sure. Yeah.
Okay, thank you. Any further questions? If not, let's close this session. Thank you very much for your very fascinating talk. Thank you. Now we have closing remarks by two organizers. Let me have a baton pass to two persons. Thank you.
Brother Heavenly, thank you for your effort in chairing
It's
the
my
previous
pleasure.
session. Yeah, wonderfully done. Lily, you should start. I missed the first presentation, as a matter of fact, but I listened. I heard it, 2 years ago. I'm sure that Professor Zhang Suojiang did an excellent job, but nevertheless, I indeed missed that presentation. So, do you wish to take the lead in making the conclusion? What is the arrangement? So, when we don't have a Q&A session, right?
No, we don't have Q&A session, but we rather just thanks these speakers, because we already discussed after the talk, after each talk. But if you wish to conclude everything, please feel free.
So,
yes.
You want me to say something, then you will start to make a concluding remarks?
Yes, I will need to go to another meeting as well. Sorry.
So you go ahead. Just a few words, please.
Oh, okay. No. I want to stay until the end, and then we can go together. So, but yes, I think maybe you can go first, Professor Shao, and I will do the rest. Yes, thank you.
All right. So so I said that I missed the first presentation, but I went through the rest. I have to say that I enjoyed every presentation of it, and I'm sure that all of you feel that it's wonderful an opportunity for us, to have takeaways. Me too, as well. And I do want to thank, all the chairs, all the speakers for your wonderful, inspiring, presentations, wonderful presentations. And also, I do have to give my compliments to NSTA, that takes the lead in coordinating in the organization of this particular conference. And my team, headed by Ali Kun, I didn't do anything. Just that when everything is arranged, they say they need a chair. I say, all right, I can be part of it. They say that's my only contribution. From the quality of the presentations, we have to say that the meeting is very well done. And I noticed on the screen that we have attracted, a handsome number of viewers, listeners, whatever they call them, that is itself a success. Primarily, the quality of the presentations, the information exchanged, and for instance, all the three sessions, the topics were very well chosen and well presented. And the first is that circular economy and biotechnology. If I remember correctly, we had five speakers. And the second session is the decarbonization and climate change. So, from the presentation, we'll see what is going on currently in decarbonizing, by using various kind of methods. Also, some of the promising modalities, approaches that we mankind are in a continued process of exploration, and we have confidence. And we listen to the European scenario, particularly the Finland story and the Nordic country story, and very encouraging. But that indeed reminds us that we are living in the same global village. We need to help each other, you know, and contribute our resources, wisdom, and thoughts to address that the biggest common challenge that mankind faces. Without partnership, we won't be successful. China is determined, okay? We have a national strategy to achieve the carbon peak, you know, by the year 2030, and the carbon neutrality by the year of 2060, and 10 years behind in the Nordic country. But as a big country, as a country that is still developing, you know, that is really a determined national goal and strategy. And we believe that in doing so, not only will protect China, the world, and also will fundamentally change the way we develop in doing our economy. The last session, of course, is really artificial intelligence. We have seen its wide use in different social aspects, including public education. It's very important to put, you know, all the important information in the digital form, okay? To educate not only, you know, the people in Thailand, you know, so the rest of the world can get access to understand, you know, your beautiful country, the rich diversity in Thailand. And of course, and I do have to give my acknowledgement, you know, to the two company guys who both did excellent presentations. So from, you know, the way we handle the processing to the packaging of mailing stuff, you know, we bring the use of artificial intelligence to achieve green sustainability. And also, you know, the Huawei story is really impressive, particularly the way he concluded his presentation. That reminds me, that's the message, the main message I have learned out of the 3 sessions. I believe you too. That is, we need collaboration, the partnership, you know, to make sure the advanced technology science is used to serve human good, for global good, and also in training the talents, we need collaboration and partnerships. So only together we can make our world a green and sustainable one. And we need your help, ANSO. ANSO is created to be an organization that does solid things. So meeting on the one hand is one part of the story, but what I wish to see as the executive director of ANSO, that is, will be some follow-ups. Let's say in circular economy, what kind of collaboration we can promote and forge, you know, between China, among the ASEAN countries, or between China and Thailand and Philippines, you know, and Japan. So it's wonderful to see that we do have speakers from the developed economies. So we together will make a better world. Thank you very much.
Thank you. Thank you so much, Professor Shao. I could not add more because I think what you have just summarized was just very completed. And I just want to thank ANSO for giving NASDAQ an opportunity for, you know, working with you on this forum. And I think we learned so much from Professor Lee Kun and her team on, you know, arranging this very important session. And I think we also learned a lot from Professor Shao, how you can, you know, summarize and, you know, and also add very important points on the collaboration as well. So I think it is good for ANSO to work together, and we are a very good example of how different countries could collaborate. So I just want to summarize and say what we prepare to say as well, a little bit official, okay? So on behalf of NSTDA, I would like to begin by expressing my sincere appreciation to all esteemed speakers and scientific and academic institutes for attending this important forum and for your stimulation, presentation, and discussion. So climate change is a complex subject, and it is important that all of its dimensions are highlighted. I think today's forum has brought many issues to our attention. Going forward from our point of view, this indicates some of the areas where we clearly need further work and discussion. If we are to converge towards any new international collective actions for green technology collaboration. There is no doubt that our ultimate goal is to come up with workable proposal for updated international mechanisms to facilitate the development and transfer of green and environmental technology. So we made a very good start today, and let us keep this momentum going by continuing to explore and further discuss potential collaboration. Thailand will be the host of Asia Pacific Economic Cooperation, or APEC, in 2022. And we do hope to bring the issue of green technology, which is also in line with our national agenda, biocircular and green economy, also called BCG, to be one of our focal issues in APEC 2022. And we, of course, welcome collaboration from our international partners. Once again, thank you for your support and participation, and I'm looking forward to our fruitful cooperation. Thank you so much. So that's the end, and thank you, and we look forward to our next collaborative session again with ANSO and also with other partners in ANSO as well. Over to you, Professor Shao. You want to say something before we go?
No. I said enough, and I do once again thank all the speakers and all the chairs and all the audience, and those ones who stick to the last minute of this conclusion. With that, let's end this meeting. Thank you.
Thank you so much, and goodbye.
Goodbye.